So thank you to those of you in the room and those who are joining us via live stream for this session on reducing global methane emissions, imperatives, opportunities, and challenges. As the pilot says, when you're about to take off, we really appreciate your being here because we know there were other airlines you could have flown, and we know that there are other methane sessions that you could have attended, but of course you came to the right one. So welcome to all of you, again, both in the room and those who are watching the streaming or, for that matter, a video recording. I'm your host and moderator, Rob Stavins, a professor at the Harvard Kennedy School, and my first function is to begin by inviting Jim Stock, who's the director of the new Salada Institute for Climate and Sustainability at Harvard University and a professor in Harvard's Department of Economics, to offer welcoming remarks. Jim.
Thanks very much, Rob. It's a pleasure being here, and I'm really glad that you've pulled together such a terrific panel for this. As Rob mentioned, I'm the director of the new Salada Institute for Climate and Sustainability at Harvard. The goal, our job at the Salada Institute, is to drive research, education, and engagement in climate and sustainability across all of Harvard. Universities, and Harvard in particular, has much that it can do in the area of driving towards climate solutions. And this research cluster on methane is an example of one of them. In all, we're funding and we're supporting 5 different clusters across the university, 2 of them on adaptation, 2 on mitigation, and 1 on energy communities in transition. Today's event focuses on work with the methane cluster and its collaborators across the globe. There's a variety of different people in cross-disciplinary areas that are participating in this. This audience needs no words of introduction as to why methane provides immediate challenges, urgent opportunities, but also the possibility of driving quick emissions reductions that could ease our transition path as we deal with more challenging carbon dioxide emissions down the road and simultaneously. So with that, let me just turn it back to Rob, and I think Rob will describe the cluster's work at a high level, and then we'll get into the substance.
Thank you very much, Jim. So the way we're going to proceed is I am indeed going to start now with some slides in which I'll give you an overview of this new initiative at Harvard, one of the 5 clusters of the Salada Institute. This is the one on reducing global methane emissions. And then we're going to turn to our panelists. First up is going to be Daniel Jacob, a colleague of mine at Harvard, and I'll give him a more complete introduction as he's about to speak. Then Claire Henly, who's from the U.S. Department of State, from the negotiating team, and likewise I'll give her more of a commentary when she begins. And then last and not least, Helena Varkkey, who's from the University of Malaysia, and we'll hear from her. And then, at that point, if I'm hoping there will be questions and commentary from the audience, we will open it up to all of you. And I don't know, Jason, if there are going to be microphones that we'll be handing around at that point or something. So with that, let me tell you about what it is that we're doing. So the first thing is to reiterate what Jim said. The motivation here is that although the quantities of anthropogenic methane are relatively small compared to CO2, obviously methane emissions can have very significant effects because of the greater radiative forcing, despite the fact that it's in the atmosphere for a much shorter time, of course, than carbon dioxide. But this means that focusing on methane can give the world time to bend the curve, as it was, on CO2 emissions. Importantly, from our perspective, conduct research on carbon mitigation and on carbon removal, and then begin to really implement longer-term strategies to mitigate and adapt to climate change. So this is not an either-or. This is not methane instead of CO2. This is methane and CO2, and for that matter, other greenhouse gases. So this is a broad-based, multidisciplinary approach, and the reason we've done that is not just to be multidisciplinary for its own sake, but because of the fact that we think that this is an effective way to produce new knowledge and to actually develop meaningful action. Those of you who are policymakers in the room are always telling us that you don't want to hear from just a single discipline on some technical work, but you want that technical work from a single discipline to be combined and to place in a broader perspective, and frequently to be combined with other perspectives. So economic analysis in a political context as one example. So because of that, this seemed like a particularly opportune time to launch a Harvard-wide methane research and engagement initiative, which is what we have done. So our goal is to really achieve meaningful and sustained progress on methane emissions reduction policies, identifying legal and regulatory opportunities for and constraints for methane emissions reduction, defining and addressing the key political issues and that are constraining attempts to reduce methane emissions, defining roles that business can play in reducing methane emissions, and then particularly here, and then finally undertaking historical examination, as one of our research teams is doing, on economic activities that result in carrying out research. Our teams are very engaged, and we are very engaged in itself. So that's an example of the sort of translation we're continuing to do under the methane initiative. And as I said, carrying out two-way communication with all of the pertinent sectors, and they're all represented here at COP28, governments, businesses, NGOs, and international organizations. And importantly, that includes governments at all levels, at the international level, regional, in the case of the European Union, national and subnational governments, jurisdictions in quite a few countries. Faculty then are working with us on translating their research into policy useful materials. In addition to publishing their work in respective journals in the various fields, which they do and will continue to do, we will be producing policy briefs and indeed videos. We're also targeting work with business leaders, which, as many of you know, in the methane realm is particularly productive in certain sectors, particularly oil and gas sector right now at the beginning, to inform emission reduction practices. So we're bringing together 17 different research groups from across Harvard University. 4 departments in the Faculty of Arts and Sciences are engaged: Earth and Planetary Science, Economics, Government, which is Political Science Department at Harvard, and History. And then 5 professional schools: Business, Engineering, Government, Law, and Public Health. And the disciplines include physics, chemistry, engineering, economics, political science, law, business, and history. Now, if you're not in academia, and particularly if you're not at or familiar with Harvard, you might think, well, big deal that they're all working together. This is virtually unique in the 350-plus year history of Harvard to be able to foster, as we are aspiring and succeeding in doing, faculty from different disciplines from different parts of the universities to work together. And so in that sense, although we're at only the first few months of a 3-year initiative, there's already been some success. And again, the reason why we think that's important is that collaborating across these research teams can enable the whole to be greater than the sum of the parts. And you know, my role as director, together with a spectacular team in the core, that's our role, is to provide the glue and to form the bridges, which we've been doing. And this means frequent interactions with all the research team, building on the synergies, and advancing cross-disciplinary understanding. Now, finally, just one example of 8 research projects that we're running in the first year of this 3-year initiative, so this is just an example, but it's a good one, is on satellite observations of atmospheric methane for U.S. reporting needs. So you notice the word U.S., let me mention, this is a global initiative. In our first year, a lot of our focus, partly because of low-hanging fruit, has been on the oil and gas sector, but we will be going into land use this year to waste, landfills, and we'll be moving into agricultural sources, both livestock and rice paddies. That'll be in the second and third year of the initiative. But this particular project we're looking at is focused on U.S. reporting needs, and we're starting with the U.S., but we are looking at a few other countries, and that will happen even more so in years 2 and 3, in addition to the global work on multinational approaches. So this specific project, the satellite observations, the goal here is to increase the value of those satellite observations of atmospheric methane concentrations for reporting and for regulation of methane emissions in the U.S., and specifically to develop near-term, real-time satellite-based monitoring system from which we are able to move, as we'll hear from Daniel in a moment, from satellite observations of concentrations to superb, very precise, remarkably so, estimates of emissions. So the idea here then is to improve reporting of methane emissions eventually later this year from landfills under US EPA's greenhouse gas reporting. So remember, each of the projects has 2 leaders from different disciplines, different parts of the university. This one has as its leaders Carrie Jenks, who's from Harvard Law School. She's obviously a lawyer. And Daniel Jacob, who's the Vasco McCoy Family Professor of Atmospheric Chemistry and Environmental Engineering, with appointments in the School of Engineering as well as the Department in Earth and Planetary Science. And with that, I think I will turn to him, but just say that here are some websites for you, in particular at the very bottom, the new Salada Institute for Climate and Sustainability at Harvard. So to Daniel Jacob.
Thank you so much, Rod, and good afternoon, ladies and gentlemen. Thank you so much for being here. Jason, you're going to activate the invitation? Yeah, thank you very much. Okay, so quantifying methane emissions is essential for climate action, but it's a very difficult task. We need to know where methane is coming from in order to know what sources to control. We need to know how much is emitted in order to be able to set quantitative goals. But methane originates from a large number of sectors involving processes that involve biology, that involve different levels of human agency, processes that are very difficult to quantify. And this is where satellites can help. Now, methane can be observed from satellites really pretty easily. You can observe backscattered solar radiation in the shortwave infrared, and methane will cry to you, "Hi, I'm here." And you can quantify it with a pretty high level of precision. And this is why we have a rapidly growing armada of satellites measuring methane. I like to separate them in 2 categories. The first one are the area flux mappers that provide regional or global mapping of methane with a resolution of typically a few kilometers, and those instruments have very high precision. Methane on pixels of 5.5 times 10 kilometers square. This is a new retrieval that was produced by my PhD student Nick Velasquez, where we have removed some artifacts from the data. This is, I think, really high quality data. And you see a bunch of hotspots associated with various sectors. You see that a lot of those hotspots are in the global south, so a challenge to control. If you zoom in on a particular region, and I'll zoom in on where we are, you see that you can provide from those satellite observations a pretty high level of few things about point sources before I run out of time. We have been spectacularly successful, and by we I mean the community, in a few weeks. Okay, and if it's cloudy, you're out of luck. But what we've been using is the NOAA GOES-R satellite. It's a weather satellite. It's not intended to observe methane, but methane is darn easy to observe if you have a big enough source. And we see this, I shouldn't say beautiful, but yes, I think it's beautiful, plume coming out of this pipe.
Biden set a goal in April of this year to raise this going forward. I'll talk a little bit about exciting developments on this. Just yesterday, there was a Dairy Methane Action Alliance that's been launched with support of Environmental Defense Fund. I think there's 5 companies now that have joined, committing to track their methane emissions. And also we had the Enteric Fermentation Research and Development Accelerator. The name was developed by scientists, you can tell. Emitted non-CO2 greenhouse gas emissions from China are greater than all of the emissions of India. They're the 3rd largest country. So I think that this issue of ensuring that these lesser known greenhouse gases are actually included in the Paris process, in the NDC, in the NDCs that are submitted by each government is so important. So if you haven't already gotten excited about that issue, I recommend getting on board for the all GHGs and NDCs alphabet soup.
Initiative for inviting me to be part of this panel. And I think what I'm going to do is following up quite nicely from Claire, which talked about the GMP, and basically I'm going to put into the context of Malaysia, who is a signatory of the GMP, and to see where we have come over the past 2 years or so. As mentioned, our project recently concluded, actually, the first phase funded by EDF. It's going to be a case study of Malaysia assessing the status, the prospects for action on methane in our country. So just a snapshot of what methane looks like in Malaysia. So we can see here Malaysia's, they have committed to net zero pathways, and this is only possible, this is only going to be possible with methane, basically looking very seriously into methane. So with this, we hope and we think that emissions should be expected to rapidly fall, especially if this action can be scaled across all industry players, the small ones and the medium ones included. Third, quantifying reductions with confidence remain challenging. So as what we heard earlier, you need both bottom-up, top-down, you need a combination of these. And even though we do have these reports coming out from the corporates as well as the government based on emission factors and such in the climate plans of our leading companies here that I mentioned. So it's really important for Malaysia to have decisive methane action even while we are planning for CO2 and other reductions as well. So what we did with all of these that we gathered together is we had a policy brief launch, and we have heard the importance of translation of the research into policy digestible format.
Enthusiasm, the whole agenda to reduce methane as well in the waste sector, and especially in the waste sector. And the waste sector has definitely a great social component, and we know that in the Global South informal sector, the community that depends, their livelihoods depend on the recovery materials, it's a really important stakeholder to take into account. So really welcome when you mention the importance of engaging CSOs in the whole methane reduction agenda, and this is definitely a recommendation that is included in our environmental justice principles that we've just launched for the methane reduction agenda in the waste sector. And I'd love that if you could elaborate a bit more, like what kind of mechanisms, how can we elaborate this further? Because we see all countries in the world that are engaged in the Global Methane Pledge elaborating the national reduction methane plans. And it's fundamental that environmental justice principles are taken into account to ensure that the money delivers truly transformational climate mitigation, climate adaptation, and we benefit of all the co-benefits that come with methane reduction, which have to do with health, with the economy, with environment, beyond emissions, etc. So, yes, thank you.
Okay, thank you so much. So the waste sector is measured as the 3rd for Malaysia at the moment for methane. And for our project, we didn't have the opportunity to look very deep into it. But if you do look into our website, we do have a small fact sheet on landfills in Malaysia, because in Malaysia, a lot of the food waste goes into landfills. So I think this is a very important thing for us to look at. And you're right, this would be a really good way to connect with the public. So I think in terms of public interest in Malaysia, we find that Malaysians actually do not really specifically know very much about methane, and they don't really even know how they themselves contribute to methane. So this is a gap that we think is important for us to think about how to fill. And I think now that you've brought it up, the waste sector is probably the best way in. So I think this is an excellent suggestion actually from you, which I will bring back to my project. And I think in terms of climate justice as well, in Malaysia we do have a big problem about food waste, similarly to what we have heard in this part of the world with buffets. You know, we have, especially during the Ramadan season. So I think that would be an entry point. We do have quite active civil societies in Malaysia looking at food waste specifically, but not from the methane angle. So I think this is something that can be brought forward as well. Perhaps that is what I can say for now. I'm sorry I cannot go into more detail because our research so far, next step will be into waste. Thank you.
Thank you. And I'm really eager to get in as many questions as we possibly can, so I'd ask you to be brief in your questions, and likewise the panel will try to be brief in their responses. And you have the microphone, sir.
Yes, hi, thank you for coming. My name is Alex Balashodis. I am Chief Commercial Officer at Trellisense, a methane intelligence startup. My question is related somewhat to that, with the uncertainty in the Harvard research and related to how you accounted for temporal uncertainty, and that it's intermittent by nature, and extrapolating to the emissions factors that you were looking at, as well as the relatively high detection thresholds compared to some of the bottoms-up methodologies.
So I think that's for Daniel, I assume.
Yeah, so very quickly, that's an excellent question. With regard to point sources, we can quantify emissions at the level of about 100 kilogram per hour under favorable circumstances, and we know this from tests that actually done with known releases that we can then test our algorithms with. As far as the intermittency of emissions, this is a very difficult thing. If you see a point source every time you pass over it, then you can say, okay, it's persistent, and I can quantify its emissions pretty well. If you see it just once and then you don't see it, you don't really know for how long it's been going and how much methane it has been emitting, unless we go to geostationary orbit. But then you need some really big sources in order to be able to see them.
Thank you. And right over there, yes?
Yeah, Nita Crawford, University of Oxford. I wanted to ask about the links between methane and nitrous oxide, in that they're co-travelers in agriculture. And can you use some of the methods that you've developed to help us understand nitrous oxide as releases in agriculture? And then basically I'm asking this because it seems like, methane we're way behind where we should be in understanding methane, but I think we're also way behind in nitrous oxide. But both have great potential for immediate impacts in reduction. So I wanted to see if you had something to say about that, in particular with agriculture and fertilizer.
So I see heads nodding on the panel. Anyone on this side who would like to respond?
I can jump in quickly and just say, totally agree. Nitrous oxide, forgotten gas, 5% of global emissions, still increasing. It is long-lived, and so I think, one of the reasons we are so focused on methane and breaking it out is because of its short-lived nature and because it's the fastest way to reduce near-term warming, but absolutely agree that there needs to be more emphasis on nitrous oxide. And we, what you were referring to is that in, for example, interventions to reduce methane in rice paddies, you can sometimes have an increase in nitrous oxide. And so there are these trade-offs that if you split out one gas, you worry that you're potentially increasing another. The Climate and Clean Air Coalition has just announced that they're going to do an integrated assessment of food and agricultural emissions, including methane and nitrous oxide, as well as a standalone nitrous oxide assessment, and we hope that that will start to increase the aperture and the focus on the relationship, but also nitrous oxide itself.
Did you want to add on the relationship between the two?
Well, yeah, so nitrous oxide also is coming from agriculture, but a very different process from methane. It comes from nitrification and denitrification by bacteria. A lot of it is associated with fertilizer use. from an atmospheric observation standpoint, nitrous oxide is extremely difficult because it has such little variability in the atmosphere. We cannot observe it usefully from space. We can observe it from surface stations, but then the interpretation is difficult.
Great, thank you. And so, for those of you who are putting up your hands, face either Rob Stowe on that side or Jason Chapman on these side. They're the ones that are passing out the microphones. I can't bring them to you. And sir, in the front row.
Hi, I'm Jerry Huang. I'm from the U.S.-China Sustainable Development Foundation. And my question here is, as we have mentioned that the U.S.-China, the Sunnyland agreements and the previous year's agreements, I'm curious, what is Harvard University's role, and how is the university and the institute leveraging its platform to deepening the collaboration with the Chinese, the government, the academic institutions, and companies? Thank you.
So one could give a very long response. I'll give you a brief one, and that is that Harvard is engaged with institutions, largely academic institutions in China, in numerous parts of the university. We have projects that have been going on for 20 years from specific faculty members, a bunch from the Kennedy School, long before anyone else, somebody named Mike McElroy from Earth and Planetary Sciences has had close engagements. We do with Tsinghua University. We're about to be doing some work, including on the methane initiative. There's a huge amount. And if you go to Harvard University website and just search for Harvard China, you will begin to see all of those. Did anyone on the panel want to add? Jim?
I'll just add that those collaborations are really an important part of what we do. It's really a great, first of all, the climate problem is an international problem, a global problem, and the U.S. and China need to work together. International negotiations, as we've seen very recently, have emphasized that, and it's the job of universities to do the same.
Sir, please.
Yeah. Hello, my name is Chen Wang. I'm a senior research fellow at the Institute of Finance and Sustainability, Beijing. I have a question specifically goes to the Professor Daniel Jacob on the technology side of the methane reduction. I really like your term about IMI is a core technology on the monitoring of the methane. My question is, in addition to the monitoring of the methane emission, are there any other breakthrough technology to really abate the methane emissions? Thank you.
Well, thank you for this question. From the atmospheric side, what we are really missing is geostationary observations, which would allow us to make observations at all times of day and to be able to detect trends and to be able to take prompt action. The fact that methane observations are limited by cloud cover or limited by infrequent overpasses is, I think, a limitation in our current capability to take action. Thank you.
So we have back there the microphone. Yes.
Tennant Reid from the Australian Industry Group. How much of a contribution to the work in satellite observation has the fall in launch costs in recent years made? And is that going to open up the possibility of a much larger number of low Earth orbit facilities to avoid this infrequent overpass issue? Or are the hardware costs the real constraint?
Well, it depends what kind of launch you're doing. The kind of launches that GSAT is doing of those microsatellites in low Earth orbit is very, well, relatively inexpensive, in a few tens of millions of dollars. If you want to go into geostationary orbit, it'll set you back $300 million, just that. And so that becomes a limitation.
Thank you. It's all yours.
Yes. Can you hear me? Daphne Weisham with Institute for Governance and Sustainable Development. Thank you for a fascinating panel. Two questions, I think probably for Claire. One is, we're delighted in the US that we have a methane fee now on the oil and gas industry, and the EPA has now proposed a $190 a ton social carbon cost, which is really exciting. How do you see that playing out within the international context? Do you have any thoughts about something like a border methane adjustment that could begin to enforce what is a strong methane signal at home to ensure that our trading partners do the same. And then secondly, Prime Minister Mia Mottley has called for a binding global methane agreement, and as chair of the Climate Vulnerable Forum, I imagine she's going to be pushing this forward. What are your thoughts on a binding methane agreement?
Yeah, happy to speak to both of those, at least in part. So one of the things that we are doing as part of our work in the oil and gas sector, the Department of Energy is partnering with, I think, 12 governments now to develop standardized monitoring, reporting, and verification system for oil and gas trade, which could be leveraged to do something along those lines. But I think the very important starting place, which actually ties a lot of this panel together in a way, is the difficulty of measuring methane emissions accurately. And in order to have any sort of a adjustment system, you need to have an agreed upon system to do that. And I think the easiest starting place is in oil and gas, and that's where we're starting with this coalition of governments, in particular the importers. And to your second question, we are, focused with urgency on the 2030 timeframe. And it's so soon. It's only 7 years away. And it's soon to be 6. And I think from our vantage point, the prospect of negotiating a methane agreement that's binding is very daunting. It's not to say it couldn't happen, and it's not to say that it couldn't have an interesting and important impact, but it would take a very long time. And so I think when we think about that prospect, that's what we worry about. Just the time that it would take relative to the time frame in which we need to act.
In terms of there being at some point a methane border adjustment mechanism, I would urge you to go to the website, go to the Salada Institute at Harvard, and then to the Methane Research Cluster, and you'll find that one of the papers we supported are external collaborators, but very much part of the initiative. Catherine Wolfram at MIT and Kim Klossing at UCLA Law School, and a colleague, and I forgot the third name, I'm sorry, who have developed a proposal and analyzed a proposal for an MBAM, and have been presenting it. And the initiative will be doing more work on that. So thanks for that question. Yes, please.
My name is Helena. I'm from the Nigerian Midstream Downstream Regulatory Authority in Nigeria. My question is to Daniel. With regards with the measurement using the satellite technology, we quite understand their limitations. I would like to find out, you put a slide up there, and are you able to tell what industry the methane is coming from? Because you had oil and gas. But we know that methane also comes from the agricultural sector and the waste sector. So in terms of accuracy of the data, is a bit general.
Yes, thank you for your question. And Nigeria is a fascinating place to observe methane because of the diversity of sources and their rapid changes. The oil and gas source is very difficult to separate from the wetland source because they are so co-located. The agricultural source we can separate because it's located more in the central and northern part of the country. One thing that we're very interested in is growing rice cultivation in Nigeria, and whether it could be contributing to a major source of methane.
Thank you. And we have a question over here. Yes, sir.
Yes, hi. My name is Ethan Weiss. I study economics and environmental policy at Swarthmore College. And the question for Claire and also you, Dr. Stavins, is there a timeline for kind of dispersing this methane detection technology to other countries and states around the world as we rapidly approach this 2030 deadline for the 30% emissions cut?
So I have no idea whether there is a deadline in the sense of theoretically when technologies would have to be distributed across countries in order to be able to achieve the 30%. Is there, so My answer is simple. I don't know. I don't know because I don't know what the technologies are. There's also a lot that can be done with existing technologies within certain sectors. So there aren't great mysteries, and that's actually the wonderful aspect of this. So, and I don't know of any modeling that's been done. Maybe others do, but I don't know of any modeling analysis that's been done quantitatively to look at the international transfers of technology required to achieve the 30%. In fact, I've seen very little analysis, at least in the economics world, of the 30% target and what will be required. But Claire, do you have anything beyond that?
I'd just say the global methane assessment does go into the sort of levers that need to be pulled. If you were asking specifically about the kind of satellite technology and data, I think we're excited to see more satellites going up very shortly, and so there will be increased data availability. The limitation right now, as far as I understand it, but is that of just availability of capacity up in the atmosphere to track everything that we might want to track. So the new satellites going up is good, but need to keep going, keep expanding that capacity.
And I believe we have a question, yes, in the first row.
Hi, my name is Leila Tai. I'm here with Northern Council for Global Cooperation, but I'm currently working in Northern Canada. My question is for Daniel Jacob. It's a fascinating model that you have there. My question is, for that kind of methane detection and reporting system, what's your vision for this kind of model get into the hands of policy and decision makers' hand? For example, the Alaska Willow pipeline just got approved a couple months ago in the States. How do you see that kind of reporting mechanism get into the hands of EPA's decision making for approving this project to get on the ground to begin with? And also, besides the assessment and regulatory, what's your vision on them considering that kind of reporting detection in the approval process? Thank you.
Yeah, thank you for this question. As far as the approval process, I'm not sure I'm able to comment, but where we are able to contribute with atmospheric observations is low latency updates of knowledge of emissions. So when you have emission inventories constructed from bottom-up methods, they are typically 2 or 3 years behind because of the need to acquire the databases. With the satellites, we can apply continuous monitoring, so we can see how rapidly the emissions evolve. We can't do anything about approval of a pipeline. We can say, well, pipelines typically emit that much, but that's highly variable. But once a pipeline is built, if it leaks, boy, we can observe it.
So I'm going to have to bring things to a close. Before I do, the question that was asked about the 30-year, about deadlines and technology transfer, it occurred to me something I should mention, just alert you to, is that one of the 8 projects in this first year of the initiative is one which is on an international basis, we're looking at abatement costs in different countries. Joe Aldi at the Kennedy School, Forrest Reinhardt at Harvard Business School, and myself. And we will have a paper on that topic available, we think, probably in the early spring. So if we get your business card afterwards, make sure you get a copy of that when it's available. And it'll provide evidence towards that. It may not specifically come up with a year that you'd like to see. But with that, I want to thank, first of all, the panelists, as well as, of course, Jim Stock, who's with us. All of you who posed questions, but beyond that, everyone who joined us this afternoon in the room or live streaming. I'll remind you again, if you'd like to maintain touch with the Harvard Methane Initiative or the other really important research and outreach initiative clusters that are part of the Salata Institute at Harvard, then if you give us a business card to Rob Stowe, right here, Jason Chapman over there, or myself, then we'll make sure that you have it. The last thing I'll say is that there is another event which is coming into this room that expects to start in 2 minutes. There is no gap between the events. Yeah, at 4:30. So I was told that there's an event at 4:30. So therefore, those of us who, if you want to talk with us, we're going to try to go outside those doors and talk outside rather than hold up another event. Again, thank you all very much.
Let's give you my card.